Everyone. In this session, we will discuss about Chomsky normal form. In this normal form, first we'll see the representation of this form, which means if a grammar is to be in the normal form, that is in the Chomsky normal form, it should be one among these two. Either it can be a non-terminal, can be a single terminal, or otherwise a non-terminal can be two different, or it can also be the same non-terminals. Okay, so this Chomsky normal form will not have any epsilon productions in it. Okay, so every non-empty language without epsilon has a grammar in which all productions are in one of the two forms. Either a non-terminal can determine a single terminal, or a non-terminal can determine two non-terminals. So if a grammar is in one of these two forms, we say the grammar is in Chomsky normal form. If the grammar is not in one of these forms, we are going to convert it into these forms. So for this, the basic step is the simplification of grammar, which we have discussed previously. So the basic steps in the conversion of the grammar into a Chomsky normal form is that the grammar should be in a simplified way. Okay, so simplified way we mean it should be free from epsilon productions, unit productions, and useless symbols. Under useless symbols, there should be no non-generating and no non-reachable symbols. So we can see eliminating epsilon productions, unit productions, and the useless symbols. All these comes under the simplification of grammar, which we have dealt previously. Followed by which, from the resultant grammar, which is free from epsilon, unit, and useless symbols, you have to introduce new non-terminals for terminals which appear in body productions of length 2 or more. Which means, if you have a grammar with a production, A determines small a, capital B. That is, we have a production like A determines small a and capital, assume it is A, okay, and capital B. Okay, so for this small a, we will introduce a new non-terminal. That non-terminal should be a new one, which should not be one among the productions given already in the grammar. So I can say, for example, R. I can introduce R. R can be A. I can write it like this. So I can now rewrite this entire A can be A, B as A can be, instead of A, I can write it as R followed by a B. Okay, so now this production A can be RB is said to be in Chomsky normal form. A non-terminal can determine two continuous non-terminals. Okay, so you will introduce new non-terminal which is not already present in the grammar for this. Okay, followed by which, for in this case we have the RHS is of length only 2. What if the RHS is of length more than 2? So if suppose I have a C here, ABC, so I will have here it is RBC. So if the RHS is more than 2, then it is not in Chomsky normal form. So at that time, we will break this into two different categories. That is R followed by something. I can name it as some X. So I will have the production as A can be Rx. Then what will be X? X will be BC. Okay, that is the last step. You will break the bodies of length 3 or more into a cascading of productions, each of which consists only of 2 variables. Okay, so we'll see it one by one with an example given. There is all this. Okay. Okay. Now this is a grammar given, and all these are the predictions. S can be ABC or BAB. A can be AA or BAC or AAA. B can be BBB or A or D. C can be CA or AC. D can be epsilon. So this I have taken this example because it covers almost all the simplification process, and all the steps of a CNF are covered in this example. So the first thing that we will do is we will eliminate the epsilon predictions. To eliminate epsilon predictions, we have to identify what are the nullable symbols. Okay, so from the given grammar, you can say the nullable D derives epsilon, so D is nullable. And then since we have B determines D, instead of D if I substitute epsilon, B also becomes nullable. So in my nullable set, I have D and now I have B. Can we include anything else? There are no more non-terminals which determines epsilon. Okay, so therefore from the given grammar I will have the nullable symbols as B and D. Now we have to substitute this nullable symbol in the prediction. So first I will write the original prediction. S can be ABC or BAB, followed by, since B is nullable, I will have AC as one more prediction. Again, for this prediction I have B repeated 2 times. So which means instead of this B if I substitute epsilon I will get AB. Instead of this B if I substitute epsilon I will get BA. Instead of both the B's if I substitute epsilon I will get A. So the first S predictions becomes ABC BAB, and then AC AB BA and A. So similarly for the A predictions, A can be AA, BAC and AAA, followed by, we have the nullable symbol B here, so followed by just AC, small a, capital C will be the second predictions. This is the prediction of A, and here B determines all these will be present, followed by, if I substitute epsilon here I will get BB. So in addition to this I will have BB. What about CA or AC? Yeah, there are no nullable symbols here, so CA or AC will be as it is. D can be epsilon will be removed as such. So this will be all these will be the resultant grammar. So from this resultant grammar we have to eliminate the unit predictions. So the resultant grammar is given in the RHS over here. Yes, over here. And now we have to identify the unit pairs. We don't have any unit pair for S, for no unit pairs for A. For B we have B, D as a unit pair. Okay, so after identifying the unit pair, I have to substitute whatever predictions for D I should be substituting here. But fortunately you don't have any predictions for D here, so you don't substitute anything. You just eliminate it as it is. Suppose if you have any predictions, D can be something, that something will be replaced in place of D. Therefore, unit pair is BD, and the resultant grammar is all those of S predictions, all those of A predictions. In the B prediction, you have eliminated D. If suppose you had D can be something that might have been replaced instead of D. Since you have nothing for D, I have not mentioned anything. And last is C can be CA or AC. Okay, so this will be the resultant grammar after elimination of unit predictions. And then elimination of useless symbols. Under that, I have the first step is elimination of non-generating. So let us see if all the grammar symbols given are generating. Does S generate? S generates, yeah, it has a single terminal. A also generates directly, has three terminals. B generates, yeah, it has a single A, and also it has two B's. So all these are only terminals. What about C? C determines CA or AC. So in this case, whenever I substitute for C, this capital C, uppercase C will be repeating again and again. Okay, so therefore I will not yield a, a string which is fully of terminals only. So therefore I can say that C is not generating. After identifying a non-generating symbol, we will eliminate it as such. Yes, so therefore wherever I will eliminate the C, I will eliminate here I have C. So when you are doing elimination of this non-generating symbols, after eliminating C, only AB must be returned. That is not the rule. C along with the entire production will be removed. Not only C will be removed. Okay. So therefore this AC will be removed fully. Not C alone and you will have only A. Doesn't mean like that. So the entire production will be removed. And here BAC will be removed and also AC will be removed. So we have removed all the C productions and the resultant will be in the resultant things in the RHS will be in the resultant grammar. So we have identified the non-generating symbol as C and S can be BAB, AB, BA or AS, and A can be AA or triple A, and B can be BBB or A or BB. Okay, now I will just erase all these. Yeah. Now with this as the resulting grammar, for with all these as the resulting grammar, yes, we will now eliminate the non-reachable. From S, B is reachable. From S, is A reachable? No. So even though it is not reachable directly, we will see at least through B if A is reachable. So from B, is A reachable? No. So therefore, from S, only B is reachable. A is not at all reachable. We will eliminate this A production fully. Okay. So you will have only this S production and also this B production. Why? Because only B is reachable from the starting state. So the non-reachable symbol is A and the resultant grammar will be, yeah, these both. So all these steps we have seen so far are the simplification of grammar. So now this will be the resultant grammar with which we are going to work further on the conversion to a Chomsky normal form. Okay. So what is it? The next rule is you have to introduce new non-terminals to terminals that appear along with other terminals as well as non-terminal. That is, whenever I have the RHS production is length 2 or more and I have a terminal in it, I have to introduce a new non-terminal. Okay, so therefore this is already in Chomsky normal form because a non-terminal can be a single terminal. It is in Chomsky. Here it is not in Chomsky and AB is also not in Chomsky. So for this A, I have to replace it with some other new non-terminal which is not either S or B. I can give X, I can give Y, I can give Z, or any names which are already not existing. Okay, and here this is already in Chomsky normal form. And for this B's, I will introduce new non-terminals. Okay. Yeah. So I will introduce R1 can be A and R2 can be B. And therefore, this S production will changes. I can change this S production to B R1B or R1B or B R1 or And this A I should not change to R1. Why? Because it is already in the CNF form. If you have a single terminal, you should not replace it. Okay. So therefore, resultant grammar becomes R1 can be A, R2 can be B. S production is changed to B R1B, R1B, B R1 or A. And how this B production will change? R2 B R2 or A or R2 R2. R2 B R2 or A or R2 R2. So now among these, this is in CNF, R2 is in CNF, and here all these three are in CNF. These both are also in CNF. The only thing is this B R1B and R2B R2 is not in CNF. Okay, so these both we have to do some cascading. Okay, so this was the result of the previous grammar, previous step. Now we have to cascade. So we have B R1B. What we can do is B followed by some R3, and this R3 will be this R1B. And here B determines R2 BR2. I can rename this BR2 to R4 and have a new prediction. R4 can be BR2. So the resultant grammar is S can be BR3. So what will be this R3? R1B. Remaining are already in CNF, so we write it as such. B can be R2 R4. R4 will be BR2. Remaining will be as such. And R1 can be A, R2 can be B, R3 can be, as we said, this R1B. R4 can be BR2, this part. So now we can say that all the grammar predictions are in CNF form because the right hand side has either two non-terminals or a single terminal. So to repeat, a grammar should be a simplified one which is free from epsilon, unit and useless symbols, and then from the resultant grammar we introduce new non-terminals to terminals that are of length 2 or more, and then we cascade the predictions such that you have only two variables on the right hand side, and that way arrive at the same. So this is the result of the grammar which is in CNF form, and this CNF form this resultant grammar which you have obtained in CNF form and the grammar which was originally given, they both will accept the same set of language. There is no change in that. Okay. Thank you.